Question number 34. There are 12 members on a board of directors. They must elect a chairperson, a secretary, and a treasurer. How many different slates of candidates are possible? So I'm going to do this in two different ways. But this question will be a permutation of choosing R objects from a total of n. And the reason why I know number 34 is a permutation of objects is because I am selecting distinct objects, which are people for distinct positions. Because we must have a chairperson, a secretary, which I'm going to abbreviate. Nah, I'm going to write the entire thing. And a treasurer. Now, I know the order matters on who goes where because the chairperson is at the top, then it's the secretary, and then it's the treasurer. So, looking at my chair, all 12 members on the board of directors is eligible to be chair. So that means there are 12 possibilities that can be chairperson. Then, when I select one person from 12 to be my chair, there are 11 people left that can be secretary. After a chair has been elected and a secretary has been elected from the 12 members, there are 10 possible people left that can take treasurer. And so when I multiply 12, 11, and 10, that equals to 1,320 different slates. Now, we can also do number 34 by using the permutation formula. And the permutation where we are choosing distinct objects and the objects are not considered identical. And I'm going to write that up here. The permutation of n objects, choosing R at a time where the order matters and you're not repeating, is equal to n factorial divided by, in parentheses, n minus r factorial. There are 12 members, so that's my n. And then we have, in this case, 3 positions: a chairperson, a secretary, and a treasurer. So R is 3, and the order does matter how I choose them, and I'm not repeating people. So that's going to be 12 factorial divided by, in parentheses, 12 minus 3 factorial. And my denominator, 12 minus 3 is 9. So 12 factorial. Let's zoom in more so we can get a better look. 12 factorial divided by 9 factorial. Maybe we zoomed in too much. Expand the top until you reach the denominator. 12 times 11 times 10 times 9 factorial. And that's going to be over 9 factorial. We can then simplify the 9 factorials. And when I simplify the 9 factorials, I am left with 12 times 11 times 10, which equals to 1,320 different slates of candidates. All right, guys, that is it for question number 34. Hope that made sense. Hope you enjoyed it. I'll see you soon. Take care. Actually, I lied. I don't want to say take care. And the reason why I don't want to say take care, although I already said it, is because I just read number 35 while I was also finishing up number 34. And that will also be a permutation in a contest in which 9 contestants are entered. And how many ways can it be how many ways can the 5 distinct prizes be awarded? The prizes are distinct and we have contestants, which means there is an order. There is an order to how somebody ranks in the prize that they get. 5 prizes. Prize number 1, prize number 2, number 3, number 4, and number 5. I'm going to do the fundamental counting principle for this case. And if you want to, you can then do the combination by hand. But after I do the combination using the fundamental counting principle, I'm then going to do the permutation in a TI-83 calculator. Now, we have a total of 9 contestants, which means 9 contestants can take the first prize. Once a person's been awarded a prize, they're not selected anymore, which means 8 contestants can take the second prize, which leaves 7 contestants for the third, 6 contestants for the fourth prize, and you have 5 contestants that can take the fifth prize. Multiply that. 9 times 8 times 7 times 6 times 5. Let's find what that is. 9 times 8 times 7 times 6 times 5. That equals to 15,120 ways that the 5 distinct prizes can be awarded. Let's do it in a TI-83/84 calculator. Now, what we're going to do is to find the permutation in the calculator in a TI-84 calculator. Type in your first number because we have 9 contestants. After that, you're going to go over to math. When you go to math, you're going to use the arrow key and go over the PRB. When you go over to PRB, you're going to click on the second option that says NPR. That is for permutation. And after that, you're going to enter in the second number, which in this case is going to be 5 because there is 5 distinct prizes. Hit enter and you get 15,120. All right, guys, that is it. And I'll see you soon. Take care.